which diagram shows the arrangement of particles inside a balloon containing a mixture of nitrogen gas and oxygen gas. So first of all, see, these are black atoms of nitrogen and these are oxygen atoms. So you can clearly see that A contains oxygen and nitrogen atoms, B contain oxygen and nitrogen atoms, C also contain oxygen and nitrogen atoms, and simultaneously D also contains nitrogen and oxygen. But how would you figure out which one is the correct option? So to understand that, you need to first understand what is a molecule, what is an atom, and what is a bond actually, right? And what is a molecule first of all? See, atom is just a single atom. Or for example, it's an oxygen atom, right? Or it could be a nitrogen atom, or it could be a hydrogen atom, right? But gases which are not inert gases, right? For example, the gases which are not reactive in the air are not very reactive, except those gases we got oxygen, nitrogen, hydrogen, and several other reactive gases. They always stabilize themselves by forming a molecule. For example, you won't find any oxygen atom. You will always find a pair of oxygen atom, which is normally called O2, which is oxygen gas, or you will find H2, right, which is also a pair of hydrogen atoms, and you will always find them in the pair. Why? Because of their reactiveness, right? They are more stabilized when they are in a pair. Otherwise, they will react with other substitute particles in the air, right? So they stabilize themselves by reacting and forming a molecule. So this is a molecule, right? A group of atoms is called a molecule, and this is just an atom. Oxygen, nitrogen, this is just an atom, singular atom, right? Now you got the concept of molecule and atom, right? And they both are, molecule or atom are fall under the category of, so if you have an atom or you have a molecule, they both fall under the category of particle, right? So never confuse between them. Now you got the idea how oxygen and nitrogen exist in the environment, right? So clearly it's option A cannot be an option. Why? Because they do not exist as single atom, oxygen and nitrogen. They always exist in pair, right? All right, now this cannot be an option as well, option D. Why? Because oxygen is making a pair with nitrogen. That could not be an option, because oxygen can only form a pair with oxygen, right, as a gas, right? Otherwise it would be a different substitute. We are only checking for nitrogen gas and oxygen gas. Oxygen gas will always be available in that form, and nitrogen will always be available in this form, right? Now only B and C are possible options, but how would you figure out between B and C? Now you can see that there is a random distribution of oxygen and nitrogen in option C, and there is segregated distribution, right? Over the top you will find the nitrogen atoms, and at the bottom you will find oxygen atom, right? And what's the reason behind that? So I have a very cool simulation to show you guys. See, we got oxygen as an atom. Let's make a molecule. So this is an oxygen molecule, and if you watch in 3D, that's how it looks like. See, this is an oxygen molecule, oxygen gas. Similarly, if I have a nitrogen molecule, this is a single atom now forming a gas, which is nitrogen gas, right? So which one do you think is more heavier? Hydrogen or oxygen or nitrogen? See, the difference is oxygen, the oxygen is more heavier than nitrogen. You can clearly see that from the size of their atom, right? Oxygen is much, not much, but it's fairly less in mass than oxygen. So the heavier the object, the more in density, and the deeper it will be in the atmosphere, right? So since nitrogen is lightweight, so it will float, and it will float above the oxygen molecules, right? So I think this is not the correct option, which is option C. Why? Because there is no random distribution. There should be a segregation. Why? Because of their difference in molecular mass. Now the correct option is option B.